Okay, well, Iceland is a relatively new geological landscape. It is only around 15 million years old, which is, as I said before, in geological terms, very young. It is situated on a constructive plate boundary on the mid-Atlantic ridge. This plate boundary allows magma to move to the surface, creating new landforms. This all contributes to being a very volcanic area. The current eruption has lasted for around 2 months, erupting large quantities of ash and gas into the atmosphere. The eruption causes many hazards, locally and globally. Some of the local hazards are damaging to crops, and there's wide-scale flooding. Some of the floods that have been experienced have had volumes of over twice the amount of flow that the Mississippi would do during flood times. Other disruptions are to do with air travel, just because of the air particles in the air, which I'll discuss later. Some past eruptions recorded from Iceland of note are from Laki Fisher in 1783. This was one of the largest eruptions ever recorded, and it was at the time of the French Revolution. It caused famine all over Europe and in several places in Asia. Benjamin Franklin, who was once the French ambassador at this time, once called it the year without a summer, just showing some of the impacts that volcanic activity in Iceland can cause. Okay, well, the ash that's been erupted from the volcano is slightly different to the normal ash that we experience from other volcanoes, for example Mount Pinatubo. The ash here is like very small, it's very small, it's like sharp glass. This allows it to travel in the atmosphere for a lot longer, as it's a lot lighter than what we've experienced from many other volcanoes. This is why it's causing such a disruption to air travel. Jet engines work by sucking in air and supercharging it with heat and then shooting out the back of the engine. When the ash goes into the jet engines, it melts, and this leaves glass deposits all over the turbines in the engine. This stops the airflow going through the engines, so the engines stall. This eruption has allowed people in aviation to really address the matter of ash in the atmosphere, especially from volcanoes. We've now managed to achieve and know what safe flying levels of ash would be. That is now worldly recognised and could save a lot of lives, especially in air travel. Okay, well, some of the future problems that we could face due to this eruption. There's the obvious impacts of how long this eruption is going to last, but possibly more worrying is its neighbouring volcano, Katla. Now, this volcano has erupted around a year after the current eruption, in its last 3 eruptions. Katla is located under 500 metres of ice, currently showing no signs of eruption. But in the past, it also has showed no signs of eruption and has erupted without any warning. Katla is set to erupt around 10 times larger than the current eruption, and this could cause massive problems throughout the world, whether it be air travel, food production, and climate change. Increased volcanic activity in the future is also a very big possibility. We geologists are looking at a term called unloading. With climate change happening more and more, it is quite clear that the ice caps are melting. We believe that with the ice caps melting, volcanic activity could quite easily increase. Ice suppresses volcanic activity. With a melting of the ice, this could allow many smaller volcanoes and possibly bigger volcanoes to erupt in the Icelandic area and in other areas covered by glaciers. This could be quite a big impact worldwide, and it needs to be addressed through the issues of climate change and on a worldwide scale. Thank you very much. Back to you in the office.